Okay, before we get into the next example, I wanted to talk about orthogonal trajectories. Now, the definition of orthogonal is a perpendicular. Some of the topics that are used in orthogonal trajectories are electrostatics, thermodynamics, and hydrodynamics. Now, let's say if I had a function where y is equal to c over x. And what we want to do is we want to solve for that value of c, which is a constant. So if we multiply both sides by x, then xy is going to equal c. So the next step that we want to do is to be able to then solve implicitly with the product rule. So if we solve implicitly with the product rule, we would get x times y prime plus the derivative of x, which is 1, and that's y, which is equal to the derivative of c, which is 0. And so now what we're going to do is we're going to take y prime, and solving for y prime, that would equal, we subtract y to both sides and divide by x. So we're going to get y prime, which is equal to negative y over x. And so that becomes the slope of the given family. Now, if you recall, whenever we talked about slope and we talked about perpendicular, to find a perpendicular slope, you would take the negative reciprocal. So if we took the negative reciprocal of this differential function, y prime would equal positive x over y, and therefore that would be the slope of the orthogonal family. So now we're going to use this differential equation here to then separate our variables. So y prime is dy over dx, which is equal to x over y. We're going to multiply both sides by y, multiply both sides by dx, and then we're going to get y dy, which is equal to x dx. And then we're going to integrate both sides. So when we integrate y, we get 1/2 y squared equals, when we integrate x, we're going to get 1/2 x squared plus c1. So if we subtract the 1/2 x squared to both sides, we're going to get 1/2 y squared minus 1/2 x squared, which is equal to c1. And now when you're looking at this, this looks like it could resemble a hyperbola. So if it does, what can we do to make it look like a hyperbola? Well, what we need to do is we need to make sure that this constant becomes a 1. So in order for us to do that, we're going to have to multiply each term by 1 over c1. So 1 over c1 times c1 is going to give us 1. 1 over c1 times y squared over 2 becomes y squared over 2c1 minus x2 over 2c1. And then we're going to let c equal 2c1, and therefore this would represent a hyperbola. We would have y squared over c minus x squared over c, which is equal to 1.